This is mixed exercise 8.01 on parametric equations. A-level, pure maths, year 2. We've got two questions. Question 1. A curve has parametric equation given by x equal to 7 cos t minus cos 7t and y equal to 7 sin t minus sin 7t, where t is between pi over 8 and pi over 3. A. Find an expression for dy dx in terms of t. B. Find the equation of the normal to the point where t is pi over 6. Give your answer in the simplest form. So for A, I have y is equals to 7 sine t minus sine 7t. I also have x is equal to 7 cos t minus cos 7t. If I differentiate y with respect to t, I get dy dt is equals to 7 cos t minus 7 cos 7t. If I do the same with the x, I get dx dt is equals to minus 7 sin t plus 7 sin 7t. So with a sin 7t and then cos 7t, I did chain rule mentally. And that's why I get 7 cos 7t here and 7 sin 7t here. The question requires us to find dy dx. So dy dx is equal to dy dt times dt dx. And so dt and dt can cancel to give you dy dx as required here. And I've got this and I've got that. And this is the reciprocal of dx dt. So dy dt is 7. And I'll factor the 7 out, and I'll get cos t minus cos 7t. And I'll multiply by the reciprocal of this. And that will be 1 over 7 bracket sine 7t minus sine t. So this becomes cos t minus cos 7t over sine 7t minus sine t. And that's the required answer for dy dx. So for B, I need to find the gradient of the tangent. And when I find the gradient of the tangent, I can easily get the gradient of the normal. So gradient of tangent to the curve when t is equals to pi on 6 is cos pi on 6 minus cos 7 pi on 6, all of that over sine 7 pi on 6 minus sine pi on 6. This is the gradient because at that point t is pi over 6, and so I've just substituted pi on 6 into the gradient function over here to get that. If I simplify that, I'm going to get root 3 on 2 minus, if I evaluate this one here, I'll get minus root 3 on 2. So all that over sine 7 pi on 6 will be minus a half. And that minus sine pi on 6 is half. Evaluate all that, and you're going to get minus root 3. So that's the gradient when t is pi on 6. That means gradient of the required normal is equal to 1 over root 3, which is the negative reciprocal of this. And that can be rationalized to get root 3 on 3. And then you need to find the coordinates of both x and y when t is pi over 6 to enable us to form the equation. So when t is pi on 6, y is equal to 7 sine pi on 6 minus sine 7 pi on 6, which is equal to 7 over 2 plus half, because sine 7 pi on 6 is minus a half, and a negative gives you positive. And that is equal to 4. In the same way, when t is equal to pi on 6, x will be equals to 7 cos pi on 6 minus cos 7 pi on 6. If I evaluate that, I'm going to get 4 root 3. So now we've got the coordinates when t is pi on 4 as 4 root 3 and 4. I can now form the required equation of the normal. So equation of the normal is given by y minus 4, which is the y coordinate here, over x minus 4 root 3 to give you the gradient of the normal, which is root 3 on 3. All I do now is cross multiply. So I get 3 brackets y minus 4 is equals to root 3 brackets x minus 4 root 3. So I can now expand to get 3y minus 12 is equals to x root 3 minus 12. You can see now that minus 12 will cancel, and I'll be left with 3y is equals to x root 3. This implies the y is equals to 1/3 x root 3. And that's the final equation of the normal required. Question 2. A curve C is defined by parametric equations. X is equals to e to the power 2t, and y is equals to 6e to the power t minus 2. A. The straight line y is equal to x plus 3 passes through the point P and Q on the curve C. Find the coordinates of P and Q. B. Another straight line, L, passes through the points A and B on the curve C, where t is equal to ln 2 and t equal to ln 3, respectively. Find the equation for L in the form ax plus by plus c equal to 0. So for A, I'll start by solving the equation of the straight line and the parametric equation simultaneously. So the equation of the straight line is given by y is equals to x plus 3. I'm now going to substitute the parametric equations into this straight line equation. And I know that y is 6e to the power t minus 2. And so this y will be replaced by 6e to the power t minus 2 equal to, and the x is e to the power 2t, and then I add my 3. I'm now going to rearrange and take these two terms on the left-hand side to the right-hand side. So if I do that, I'm going to get e to the power 2t minus 6 e to the power t plus 5 equals to 0. Plus 5 because 3 plus 2 is 5. Then I'll rewrite this term using the laws of indices as follows. E to the power t, all of that raised to the power 2, minus 6 e to the power t plus 5 equals to 0. So if I say let n is equals to e to the power t, then this equation becomes n squared minus 6n plus 5 is equals to 0. I can now factorize to get n minus 1 times n minus 5 equals to 0. So I can solve for n to get n is equals to 1 and n is equals to 5. But we said n is equals to e to the power t. So I have either e to the power t is equals to 1 or e to the power t is equals to 5. Now I'm going to solve these two equations to get the values of t. I can say that e to the power t is equals to e to the power 0 because e to the power 0 is 1, and that means that t is equals to 0. So that's one of the values of t. For this equation, if I take logs, I'll have ln e to the power t equals to ln 5. This means that t is equals to ln 5. So now I've got two values for t. I can now go ahead and find the x and y values corresponding to these two values of t. So let's start with when t equals to 0. So when t equals to 0, x will be equals to e to the power 0. Because if I put 0 here for t, I'll get 0. And that means x will be equals to 1. In the same way, when x equals to 0, y will be equals to 6 e to the power 0 minus 2. Because I put t equals to 0 here. And that will evaluate to give me 6 minus 2. And that is 4. So that will give us the x and y coordinates of p. P will be given by 1 and 4. And then we'll do the same thing for when t is ln 5. So when t is equals to ln 5, x will be equal to e to the power 2 ln 5. That will be the same as e to the power ln 5 squared. And so this gives us e to the power ln 25, which is 25. And so for y, we're going to get, so when t is ln 5, similarly y will be equal to 6 e to the power ln5 minus 2. And this will be 6 times 5, because the whole of that is 5 minus 2. This is 30 minus 2, which gives 28. This means that the other point, which is Q, will be 25 and 28. For B, we are asked to find the equation of L, where L crosses C, which has the following parametric equations. So x is equals to e to the power 2t, and y is equals to 6e to the power t minus 2. When t is equals to ln 2, that's the first point, I can put ln2 in this and ln2 over there, and I'm going to get the s coordinate will be e to the power 2 ln2, which is the same as e to the power ln 2 squared using the laws of logs, and that will be e to the power ln 4, and that is equal to 4. When t is ln 2, the y coordinate will be given by y is equals to 6 e to the power ln 2 minus 2. Using this equation here, this will be the same as 6 times 2 minus 2, because e to the power ln 2 is 2, and that will evaluate to give me 10, because 6 times 2 is 12, 12 minus 2 is 10. So there, the coordinates. A will be 4 and 10. If I do the same calculations for when t is equals to ln 3, the x coordinate will be equals to e to the power 2 ln 3, which is the same as e to the power ln 3 squared, which is e to the power ln 9, and that gives me 9. And then doing the same thing for the y, I'm going to get 6 e to the power ln 3 minus 2. This will be equal to 6 times 3 minus 2, and that will give us 16, because 6 times 3 is 18, 18 minus 2 is 16. So the coordinates for B, you can say, is 9 and 16. We can now find the equation of the line. So equation of L is given by y minus 10 over x minus 4 is equal to 16 minus 10 over 9 minus 4. Because we've got 2 points, we can use this equation here. This is the gradient, y minus 10 and x minus 4, using this point, gives us the gradient. And so will 16 minus 10 and 9 minus 4, using this point and this point. And so we can now simplify that. That will give us 6 over 5. So if I cross multiply, I'm going to get 5 brackets y minus 10 is equals to 6 brackets x minus 4. Expand that, 5y minus 50 is equal to 6x minus 24. Rearrange to get it the form they want, like that. You're going to get 6x minus 5y plus 26 is equal to 0. Plus 26, because when I take this one to that side, I'm going to get 50 minus 24, which is 26. And so this is the equation of L in the form required. And this brings us to the end of this session on parametric equations.